So, question 1, part A, we are asked to write the function given in this form. So this is quite a nice question to start an exam paper. We are told f of x has this form up here. We are given this, so if we say a times x plus h to be squared plus k, and what we are going to do is just multiply this out, and we will get a times x squared plus 2xh plus h squared plus k, and we get ax squared plus 2axh plus ah squared plus k. And if we write this f of x down here, we have 2x squared minus 7x minus 10. So we're just going to compare like with like. So we have ax squared and 2x squared. So obviously a is equal to 2. We have 2axh is equal to minus 7x. So if we cancel those x's, and we want to find h, so we want this value. So that gives us that h is equal to minus 7 over 2 times a. We know a is equal to 2, so h is equal to minus 7 over 4. So then we are left with ah squared plus k. So we have ah squared plus k is equal to negative 10. We want to find the value of k. So we have k then is equal to negative 10 negative ah squared. So we have minus 10 minus a, we know is 2, times h is minus 7 over 4 to be squared. And that is equal to minus 10 minus 2 times 49 over 16. So that will give us an 8. And that is equal to, well, this is minus 80 over 8. Minus 49 over 8 is minus 129 over 8. So now we have a, h, and k. We'll just substitute them in to this formula here. And we will get 2 times x plus h, which is minus 7 over 4, to be squared, plus k, which is minus 129 over 8. And that is part A complete. So for part B, we want to find the minimum point of f. So we have written now that f of x is equal to 2 times x minus 7 over 4 to be squared minus 129 over 8. Since this term here is squared, it will always be positive. So f of x will be at a minimum when this term goes to 0. So f of x will have a minimum when x minus 7 over 4 is equal to 0, which is going to happen when x is equal to 7 over 4. When x is equal to 7 over 4, f of x is equal to minus 129 over 8. So then we have the coordinates are 7 over 4 and minus 129 over 8. And at this point, f of x will be a minimum. So part C, part 1, explain why f must have 2 real roots. Okay, so it all depends on the discriminant. We know the roots are given by x is equal to minus b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So this term here, b squared minus 4ac, is called the discriminant. If this is less than 0, then we have the square root of a negative number, less than 0, we have the square root of a negative number, so this is imaginary. If it's imaginary, it has no real roots. If it's equal to 0, then this term vanishes, and we're just left with minus b over 2a, so it only has one root, which is repeated twice. And if it's greater than 0, then this term will be positive, so we will have two different real roots. So we want to show that if it must have two real roots, then b squared minus 4ac must be greater than 0. So b, I just check up here, is minus 7, and c is minus 10, and a is 2. So we have minus 7 to be squared minus 4 times a, which is 2, times c, which is minus 10. So we have 49 minus 80, which is equal to 49 plus 80, which is greater than 0. So f must have two real roots. And for part 2, we want to write the roots f of x equals 0 in this form. Well, we nearly have this done. So if we just take a look at this, it will have x is equal to minus b, which is minus 7, which is 7, plus or minus the square root. We just calculated this to be 129. That's all over 2 times a, which is 4. So that is equal to 7 over 4 plus or minus the square root of 129 over 4. We can see we wish q for everything to be under the square root, so we'll just rewrite this as 7 over 4 plus or minus the square root of 129 over the square root of 16. And then that is equal to 7 over 4 plus or minus the square root of 129 over 16. Okay, so they are the roots of f of x equal to 0 written in this form. And that is question 1 complete.